Hello everyone at Medical Sciences. We are always privileged to have you, serving you, and bringing medical sciences at the comfort of your workplaces or at your home. So in this video, we are looking at water purification methods. And today we want to look at what we call water deionization using a machine known as a water deionizer. You can ask yourself, why do we need to purify water? By removing minerals. So its other name, we can call it demineralization. Demineralization. Because this method looks at the removal of minerals. That is what we are calling a water deionizer. So it is responsible for water purification, but only it looks at removing of minerals from water. And minerals include cations, it includes anions. So this is what we call a water deionizer, a method used to purify water, because water comes with impurities. For example, the hard water containing minerals such as cations and anions. Cations are positively charged ions. These ones are positively charged, whereas anions are negatively charged ions. So some of the minerals which can be found in hard water include, we shall see minerals like magnesium, minerals like sodium, potassium, calcium. All these are cations which can be found. Whereas the anions can be like chloride, phosphate, you can have the sulfate ions. All these can be found in water. So we want to see how can we get rid of these anions and the cations from water so that we can use this water for many activities in the lab. For example, we can use demineralized water for preparation of reagents in the lab. That is one of the use of deionized water. We can use it to wash lab materials like cuvettes, like glasswares, so that especially when we want to do tests like electrolytes, so that they are not contaminated. So preparation of reagents, stains, washing lab equipments like cuvettes and other glasswares, and also in routine cleaning up of lab equipments, we normally use deionized water. And how does it, or how do we make water free of ions? So when we have an impure water, here we have the impure water, and this impure water is containing these cations and anions. So it contains sodium, potassium, magnesium, then calcium, and others. Then it contains cations such as the chloride anion, such as the phosphate anions. So this water which is impure, when it is fed into two different exchange resins, because it works under the principle of ion exchange. So we're going to see this deionizer working under the principle of ion exchange. So we have two compartments in the deionizer. The first compartment is the cation resin, cationic cation resin, or that is the cation exchange resin. Then we have the anion exchange resin. And the cation exchange resin contain hydrogen ions. It contains hydrogen ions within it. It contains the hydrogen ions, whereas the anion exchange resin is made up of the hydroxyl ions. These are the ones in the anionic resin. So this resin is made up of a polymer a long polymer chain together with an acidic component, and here the acidic component we can use is like the sulfate, anion, then together with the hydrogen ion. So the whole resin contains these three components, where R is representing a long polypeptide chain having the acidic component, which is the sulfite, in this case with the hydrogen ion, or what we can call a proton. Whereas the anion resin is going to contain the polymer chain together with the basic resin, and the basic resin we can use here is like the ammonium resin, then together with the OH group. And you can ask yourself these two different resins having the hydrogen. So here the key player in ion exchange, we are going to see the hydrogen ions. Then here we are going to see the hydroxyl ions. These are the ones which are going to be exchanging with the different, whereby this one is going to exchange with the cations, whereas this one is going to exchange with anions. That is what we are calling the principle of ion exchange. So this one, how does hydrogen ion exchange with the cations? It works under the component of what we call reactivity series. You remember components in group 1 and group 2, they differ in their reactivity series, whereby here we are using hydrogen because it is among the reactive components which are least reactive, whereas hydroxyl is among the anions which are least reactive according to the reactivity series. So meaning, since hydrogen ion is lower in reactivity series, other components are able to displace. So if you have a component sodium which is on top in reactivity series, then you have the hydrogen which is below, then this sodium which is higher in reactivity series has the ability to replace or to displace. It is like when you're dating a lady and you don't have sweet words, then another person comes having sweet words, is able to displace you. That is what we are talking about under reactivity series. So in this case, so this impure water is coming in containing these cations, which we have seen like sodium, like potassium. But don't forget it has also anions like the chloride, like the sulfate, and so on. So when these cations are passed through what we are calling the cation exchange resin, what happens? This sodium being highly reactive than hydrogen ion, it is going to come and displace this hydrogen ion, hence comes and takes over. So in illustration, we have the cationic resin. This is the polymer chain. It is having the acidic substance, then with the hydrogen ion. So if the impure water is coming having cation like sodium, that sodium being highly reactive, it is going to come and displace the hydrogen. It displaces the hydrogen away from the resin, and we are able to form R and sodium, then plus the hydrogen which is displaced. So that is the mechanism we are looking at taking place under cationic resin. That because the water which is coming with the sodium, with the potassium, with the magnesium, with the calcium, since they are highly reactive than the hydrogen ion, they come and displace hydrogen ion from the resin, and when it is displaced, it remains lonely. The way I use that example when you're dating a lady, and because of lack of money or little words, someone comes. So it means the sodium has sweet words, or it has enough money. And because it has sweet words plus money, whereas hydrogen has no sweet words, I'm joking with this example, he doesn't have money. So this one, sodium, which has enough money and sweet words, is able to displace hydrogen from its own girlfriend. Then this one is able to come and conjugate with the girlfriend of hydrogen, and hydrogen remains lonely. That is how I can explain it. So here I have used the sodium, but other cations can be magnesium, can be potassium, can be calcium. They do the same of displacing the hydrogen ion. Then what happens under the anionic resin? So when this water passes through, it means by the time it passes through the cationic resin, it is free from any cations. Now we are remaining with only anions. That is the chloride, the sulfate, and the phosphate. They are the only one remaining. So these ones, they are going to continue moving with water. They move with water and they enter into what we call the anionic resin. And in this, we have only chloride, the sulfate, and the phosphate entering. So when they come and pass through this cationic resin containing the hydroxyl group, what happens is that this resin, which contains the hydroxyl group, and remember the hydroxyl group is weaker in reactivity. So if I bring an anion, such as the chloride, which is highly reactive than the hydroxyl group, because it has sweet words or enough money, it's going to come and tells the hydroxyl group that please go and work. For me, I have money and I have sweet words, so it's going to come and displace the hydroxyl group from its girlfriend. Then it takes over. Then this hydroxyl group is going to remain lonely. So at the end, the result is RNH4. Then it is no longer the hydroxyl group binding to the girlfriend, but it's the chloride, because it is highly reactive, or it is very sharp than the hydroxyl group. So we shall leave the hydroxyl group lonely. That is what happens in the anionic resin. So now you can imagine this one, if is maybe you can name is can be like John, James, who is lonely and is going to meet also Sarah, who has been displaced by the boyfriend. So what is happening, because all of them have been chucked by their counterparts, so they are going to say we can join together and also make marriage. So we're going to see the displaced hydrogen ion at the end. The displaced hydrogen ion comes and conjugates with the displaced hydrogen hydroxyl group, and they are able to form pure water. This water, which is demineralized. This water is demineralized. So it is free from minerals. So this is what we call the ionized water. That is how it is formed. But this water, I want you to note that it is not free from microorganisms, pyrogens, they are there. But only what lacks is the minerals. So this process only aims at removing the minerals from water so that we can get mineral-free water, which we can use in the laboratory to prepare different reagents, stains, and wash lab glasswares. So this is what we can discuss with you under water deionization, which works under the principle of ion exchange, whereby we have seen in the cationic resin, it has two resins, the cationic exchange resin and the anionic exchange resin. And the exchange occurs due to difference in the reactivity of different minerals, whereby the one which is higher in reactivity series displaces the one which is lower. And that's how we are able to see the cation is displacing hydrogen, because hydrogen ion is the less in reactivity series. And then we are seeing hydroxyl group being displaced because it's the least under the anions in reactivity series. And the end, they will displace hydrogen and hydroxyl group. And when they combine, we form deionized water, which we can now use in the laboratory to do different activities. Thank you so much. Hope you have enjoyed our video. Please remember to subscribe, like the video, and we can be able to make more others like this.